Okay, here, let's do a quick description of how the intensity of light changes when it passes through an ideal polarizer. This is very straightforward, and I imagine that you're probably familiar with it, but it'll just take a second to remind ourselves how this works, so it's worth doing. So here's our situation. Light of some polarization at some polarization angle n is going to strike a polarizer, an ideal polarizer, which has some orientation described by unit vector np, and then proceed. What's the, how does the intensity of the light change as it crosses through the polarizer? Okay. Well, this is easy to describe. We know that what the polarizer will do is it will select out the component of the light that's polarized along the transmission axis and pass that, and it will reject, reflect, or absorb the rest. So schematically, the original electric field vector looks like this. It's pointing in the direction NP, and I'm sorry, N. And what the polarizer will do is it will select out the component that's polarized parallel to the orientation direction of the polarizer and reject the component that's perpendicular to it. So clearly, if the original electric field had some magnitude E0 and it's pointing in the N direction, then the magnitude of the component that's transmitted will just be E0 times N dot NP, or E0 cosine theta, where theta is going to be the angle between the original polarization and the transmission direction of the polarizer. Straightforward enough, right? Finally, the intensity of the light is proportional to the magnitude of the electric field squared. So if the original intensity was I0, then clearly the final intensity would be I0 times cosine squared theta. That's a familiar result that's sometimes called the law of malice. Where malice is somebody's name, it doesn't denote ill will towards you or anyone else. Any event, that's what a polarizer does to a linearly polarized wave. But more generally, for any type of polarization, of course, it just selects out the component polarized parallel to the transmission axis of the polarizer.